What if everything we thought we knew about the first Americans is wrong? Deep in the high desert of southern Oregon, archaeologists have uncovered something that is shaking the foundations of human history. Beneath layers of ancient volcanic ash, preserved like a time capsule, lies evidence of human activity dating back nearly 20,000 years. That's thousands of years earlier than the timeline most textbooks have confidently taught for decades. For generations, experts believed the first people arrived in North America around 13,000 years ago, crossing a land bridge from Siberia during the last ice age. It was a neat, clean story, simple, predictable, settled. But this discovery tells a different story. Stone tools, animal bones, and signs of human survival have been found at a site known as Rimrock Draw Rock Shelter. The artifacts were buried under ash from ancient volcanic eruptions, locking them in place and preserving a moment from a world long gone. When scientists tested the layers, the dates pushed human presence in North America back by thousands of years. If people were here 20,000 years ago, how did they get here? What routes did they take? And what else have we completely misunderstood about our past? Before we reveal what we found, hit like and subscribe right now. Because the truth about our past is only getting more shocking. The site that was never supposed to exist. Rimrock Draw looks harmless at first glance. It is a shallow rock shelter carved into a low rise in central Oregon, far from coastlines, far from ice corridors, and far from anywhere archaeologists believed early humans could survive. For decades, this region was treated as empty during the Deep Ice Age, written off as too cold, too dry, and too isolated to matter. According to accepted history, people arrived much later and passed through completely different routes. Rimrock Draw was not supposed to hold anything important, and that assumption kept it untouched for generations. When archaeologists from the University of Oregon finally began excavating the site, they were not looking for early humans at all. Their goal was modest and safe, to study Ice Age animals and environmental changes, not to challenge long-standing theories about human arrival. Based on everything archaeology had taught them, they expected shallow debris from the very end of the Ice Age, mixed soil, and natural deposits left by wind and erosion. No one expected the ground to fight back against the timeline. Almost immediately, something felt wrong. As digging began, the sediment did not look disturbed or chaotic, which is common in open shelters exposed to weather and animals. Instead, the layers appeared clean, flat, and sharply separated. Nothing had collapsed into lower levels or been dragged down by roots or washed in by water. In archaeology, this kind of preservation is rare, and when it appears, it demands attention. Each layer sat exactly where it formed, stacked neatly on top of the next. Dark bands marked periods of activity, while lighter bands showed pauses where the shelter went unused. This created a clear, readable sequence, like pages laid in order rather than torn from a book. As the team moved deeper, the evidence became older, in a way that followed every geological rule. There was no easy way to dismiss what they were seeing. Then came the signs of human presence. Stone tools appeared, not scattered randomly, but placed within specific layers. These tools were not isolated mistakes or objects carried in by chance. They appeared again and again at different depths, separated by long spans of time. That pattern meant people returned to this shelter repeatedly. This was not a single visit or an accident. It was a location that people remembered and reused. That realization alone was deeply unsettling. According to accepted models, humans should not have been here at all during these periods. The environment was believed to be too harsh, with limited food and brutal seasonal conditions. Yet the evidence showed controlled activity, tool use, and repeated occupation. The site behaved like a known destination, not a desperate stop. As excavation continued, the deeper layers pushed farther back in time. Every inch downward made the contradiction worse. The tools remained consistent with human workmanship. The layers stayed intact, and nothing suggested later contamination. The site obeyed the rules of archaeology while breaking the rules of history. From the moment these layers were exposed, it became clear that rimrock draw did not fit into the existing story of how and when humans arrived in North America. The problem was not one strange object or one unclear date. It was the entire structure of the site. Everything about it followed the rules of archaeology, except for where it sat in time. That quiet contradiction turned into open shock when researchers reached a layer sealed beneath volcanic ash and uncovered one specific object that could not be ignored. Buried there was an object that forced the timeline to collapse completely, the camel tooth that shattered the timeline. The moment that changed everything came from a single animal that was never supposed to be part of this story. Buried deep inside rimrock draw, archaeologists uncovered teeth and jaw fragments belonging to Camelops hesternus, an extinct giant camel that once stood nearly 7 feet tall. This species vanished from North America thousands of years before humans were believed to have reached Central Oregon. Its presence alone was troubling, but where it appeared in the ground made it devastating. The camel remains were not scattered randomly, as would be expected if an animal had simply died nearby or been dragged in by predators. Instead, the bones were clustered in a tight area, the way remains appear when an animal has been deliberately processed. This pattern immediately raised concern because natural forces do not arrange bones this way. Closer inspection made the situation worse for the old timeline. Clear cut marks were visible on the camel bones, and they were not shallow scratches or vague surface damage. These marks followed straight, repeated lines and appeared at joints where meat is normally separated. This is exactly what stone tools leave behind when used to butcher large animals. Carnivore teeth, trampling and erosion leave different kinds of damage, and those patterns were not present here. The marks matched human activity, and there was no reasonable alternative explanation. The location of the remains sealed the argument even further. The camel bones were found beneath a thick layer of volcanic ash from a known eruption of Mount St. Helens. This eruption has been dated independently by geologists and occurred more than 15,600 years ago. Volcanic ash spreads rapidly and settles evenly, creating a clear time marker across large regions. Once it falls, anything beneath it cannot be younger than the eruption itself. This matters because the ash layer at rimrock draw was intact and undisturbed. It had not been broken, mixed, or penetrated by later activity. That means nothing from above could have fallen into the layer below. The camel remains were sealed in place, locked beneath a geological timestamp that could not be argued away. This alone forced the evidence to be older than 15,600 years, already far earlier than the Clovis timeline allows. Then came the radiocarbon results. Scientists dated the camel tooth enamel directly, removing any guesswork about association. The result came back at approximately 18,250 years before present. This was not a borderline date or a weak estimate. It placed the camel, and the human activity tied to it, thousands of years earlier than the long-accepted arrival of humans in North America. At this point, coincidence was no longer possible. For the old timeline to survive, multiple independent systems would all have to be wrong at the same time. The species identification would have to be mistaken. The cut marks would have to be misread. The volcanic ash dating would have to be incorrect. The radiocarbon analysis would have to fail. And the undisturbed sediment layers would have to lie. Archaeology does not collapse unless every one of these supports breaks at once. And here, they all held. This meant humans were present in Central Oregon during a period when massive ice sheets still dominated much of the continent. According to older models, people should not have been hunting large Ice Age animals here at all. Yet the evidence placed them there clearly, directly, and without room for escape. The camel tooth did not suggest a possibility. It delivered a verdict once it was documented, dated, and verified. The Clovis first timeline could no longer stand untouched. But this new reality did not just threaten to adjust history. It cracked it. And if humans were here long enough to hunt and butcher massive animals, they did not arrive empty-handed. If people were present at Rimrock Draw this early, their tools had to be nearby. And those tools would carry evidence even harder to dismiss. Stone tools that confirm deliberate human activity. After the camel tooth destroyed the timeline, archaeologists still needed one final thing to remove any remaining doubt. They needed proof that humans were not only present, but actively working at Rimrock Draw. That proof came in the form of stone tools found in direct association with the camel remains. These were not random stones cracked by pressure or erosion. They were shaped objects with clear purpose, and once they were examined closely, ambiguity disappeared. The tools were stone scrapers, carefully formed with sharp working edges. Natural breakage does not create this kind of shape. The edges were intentionally flaked to create controlled cutting surfaces, and the overall form was consistent from tool to tool. This kind of consistency only appears when someone is making tools with a specific function in mind. These were not experiments or accidents, but finished tools. What made the discovery more unsettling was the material itself. The scrapers were made from orange agate, a stone that does not occur naturally near Rimrock Draw. Local rock types are different, and none match the color, texture, or fracture pattern of the tools. This means the material had to be brought in from elsewhere. Either the people who used these tools traveled long distances to collect it, or they obtained it through exchange with other groups. In either case, this showed planning beyond immediate survival. The edges of the tools told an even clearer story. Under magnification, archaeologists could see wear patterns that only come from repeated cutting of meat and hide. The edges were smoothed in specific areas, and tiny fractures followed predictable paths caused by pressure against soft tissue and bone. These patterns are well documented in experimental archaeology, where modern replicas are used to butcher animals. The wear on the Rimrock Draw tools matched those results closely. These scrapers were not made and abandoned. They were used again and again. One tool pushed the timeline even further back. A scraper was found in a sediment layer deeper than the camel remains. This placed tool use at Rimrock Draw earlier than 18,250 years ago. Because sediment accumulates over time, deeper layers are older and less disturbed. At this site, the layers were clean and intact. There was no evidence of digging, burrowing, or water mixing that could move objects downward. The depth alone showed that humans were present before the camel was butchered. The sediment itself mattered as much as the tools. The scrapers were found embedded in stable, compact layers, not loose or mixed soil. This confirmed they were deposited when those layers were forming, not introduced later. In archaeology, disturbed layers are a warning sign. But at Rimrock Draw, there were no such warnings. The ground preserved a clear sequence, and the tools sat exactly where they were left. The shape of the tools removed the last excuse for doubt. These scrapers were not multi-purpose stones picked up and discarded. Their edges were shaped at angles ideal for scraping hide and cutting flesh. The grip areas also showed signs of repeated handling. Someone had designed these tools to do specific jobs, and they worked long enough to wear down. Together, the material choice, shape, wear patterns, and depth placement formed a single message. Humans were not passing through Rimrock Draw by chance. They were stopping, working, processing animals, and returning. This was not a one-time event, caused by desperation or accident. It was repeated, deliberate activity. At this point, the argument was no longer theoretical. The tools were physical actions preserved in the ground. Someone stood here, held these stones, and used them with purpose. The timeline was not bending anymore, but breaking. The final confirmation came from evidence so small it could only be seen under a microscope. Yet it carried the most direct proof of all, residue evidence that removed all remaining doubt. By the time the stone tools were analyzed, the argument was already under strain. But what finally ended, it came from evidence so small it could not be seen without powerful equipment, and yet so precise that it erased every remaining alternative explanation. This was residue analysis, a method used to detect microscopic traces left behind when tools are used on living material. It does not rely on guesswork or visual interpretation. It relies on chemistry and biology. Residue analysis works by examining tiny cracks and surface fractures on stone tools. When a tool is used to cut meat or scrape hide, fluids and proteins from the animal are forced deep into these microscopic spaces. Over time, those traces dry and become trapped. To reach these cracks, the tool must be actively cutting or scraping animal tissue. At Rimrock Draw, scientists selected stone scrapers that had already been identified as working tools based on shape and wear. These tools were carefully cleaned to remove modern contamination, then tested in controlled laboratory conditions. Using protein residue analysis, researchers were able to isolate biological markers still preserved inside the stone. What they found was not vague or uncertain. The residue matched the blood proteins of Bison antiquus, a large Ice Age species that went extinct thousands of years ago. This was not modern bison and not a closely related animal. The protein signature was specific and recognizable, meaning the tool had been used to process a bison carcass directly. There was no scenario where this blood could appear by accident. Bison blood cannot enter a stone tool through groundwater, wind, or sediment movement. The only way these proteins become embedded is through cutting flesh or scraping tissue while the animal is fresh. Someone used that tool on a living or recently killed animal. This evidence locked three separate elements into the same moment in time. The stone tools, the butchered animals, and the humans using the tools were now connected biologically, not just spatially. The tools were not objects lying near animal remains by coincidence. They were the instruments that acted on those animals. The connection was direct and physical. The species identification mattered as much as the residue itself. Bison antiquus was a massive animal, larger than modern bison and dangerous to hunt. Processing such an animal requires planning, skill, and cooperation. This was not small game scavenging or survival improvisation. It was organized big game activity, taking place far earlier than accepted timelines allowed. At this point, the argument could no longer be reframed or delayed. The tools were used, the animal species was identified, and the activity was dated. Each line of evidence supported the others without contradiction. Remove one, and the rest still stood. Residue analysis did not add a new theory to rimrock draw, but closed the case. Now, human activity was no longer inferred. Rather, it was measured, identified, and preserved at a molecular level. The site had gone from suggestive to conclusive, with human presence confirmed beyond dispute. Long-standing theories about when and how people entered America could no longer survive unchanged. Why the Clovis first theory can no longer survive. For most of the 20th century, the Clovis first theory acted as a fixed boundary for American prehistory. It claimed that humans entered North America around 13,000 years ago, moving from Siberia into Alaska and then traveling south through an inland ice-free corridor between two massive ice sheets. Everything else was expected to fit inside that window. Rimrock draw does not fit, and the reason is not interpretation, but timing. The camel tooth and tools at Rimrock draw date to about 18,250 years ago. That date alone creates an immediate problem. At that time, North America was still locked in the Last Glacial Maximum, a period when ice sheets were at their greatest size. The Laurentide ice sheet covered most of Canada, while the Cordilleran ice sheet blocked the western interior. These two ice masses were not separated by a usable corridor, and geological data shows that the inland passage did not open until thousands of years later. This means the core requirement of the Clovis first model fails under direct comparison with the Rimrock draw timeline. Humans cannot move through a corridor that does not exist. There is no geological evidence of an open, stable route through the ice at 18,250 years ago. Rivers, plants, and animals that would have supported travel were also absent. The land was frozen, unstable, and largely uninhabitable. If people were already in Central Oregon at that time, they could not have arrived using the Clovis route. This is not speculation, but a simple conflict between dates and geography, and one or the other must be wrong. The ice data is independently confirmed across multiple studies and locations. That leaves the theory. The only remaining explanation that fits both the dates and the physical landscape is early coastal movement. The Pacific coastline was not fully frozen. Even during peak glacial conditions, kelp forests along the shore created a continuous, food-rich environment known as the Kelp Highway. This route would have allowed humans to move south by following marine resources instead of crossing ice-choked land. This type of travel requires skills that were once denied to early Americans. Boats or watercraft would have been necessary, and navigation along shifting coastlines would have required planning and knowledge passed across generations. The Rimrock draw evidence supports this level of ability. The stone tools, material transport, and repeated site use show organized behavior, not accidental wandering. Clovis first also assumed that early humans spread quickly after arriving. But Rimrock draw shows something different. Humans were already established, adapting to local environments, hunting large animals, and returning to known locations long before Clovis tools appear in the record. This suggests Clovis technology was not a beginning, but a later development within an already existing population. Importantly, the Clovis first theory did not collapse because archaeologists wanted a new story. It collapsed because its conditions no longer match the evidence. The ice dates, the geographic barriers, and the Rimrock draw findings cannot be made compatible through reinterpretation. There is no adjustment that preserves the theory without ignoring data. Yet, even more unsettling is the possibility that Rimrock draw is not the earliest site at all, but only the first one clear enough to force this change, evidence that suggests an even older human presence. The camel tooth dated to 18,250 years ago is only part of the story. Archaeologists noted that it was not at the bottom of the sediment layers in rimrock draw. Beneath it lie deeper deposits containing stone fragments and subtle marks of human activity. These lower layers have not yet been fully analyzed, but their existence suggests humans were present long before the camel was butchered. The principle of superposition makes this clear in undisturbed sediment. The deeper a layer is, the older it must be. Rimrock Draw's deposits are remarkably intact. There are no signs that the soil has been mixed by water, animals, or later human activity. This means that anything found deeper than the camel tooth is almost certainly older, providing a secure chronological framework. Some of the stone flakes and debris in these lower layers already show patterns similar to the tools associated with the camel. Their presence indicates planning and repeated use, not a single accidental occupation. Even without radiocarbon dates, their depth alone implies a much earlier human presence. The site, as it currently stands, is already far older than the long-accepted Clovis horizon. But these untouched layers hint at a timeline that could extend well beyond what anyone expected. Excavation has not reached the bottom of the shelter. Funding limitations, preservation concerns, and the need to protect fragile deposits have kept archaeologists from fully exposing the site. This means the full story of human settlement in the region is only partially revealed. Each untouched layer adds to the suspense, as it might contain tools, remains, or other evidence that could rewrite history again. With each layer that lies deeper, the gap between established theory and the evidence grows. The deeper deposits contradict decades of assumptions about when humans arrived in North America. They challenge the idea that humans had to wait for ice-free corridors or favorable inland routes. The possibility that the earliest settlers were already present along the Pacific coast 20,000 years ago, or even earlier, forces a rethinking of migration, adaptation, and survival strategies. Archaeologists are cautious but clear about the implications. The evidence does not just push back the timeline, but suggests that our understanding of human arrival is incomplete. The lower layers of rimrock draw may contain the remains of people who lived, hunted, and survived under conditions far harsher than previously imagined. If confirmed, these layers would make the camel tooth seem like a middle chapter rather than the first word. Rimrock draw suggests that what we currently know is only a small part of a far older and more complex human presence in North America. And it changes everything. Why rimrock draw changes everything going forward. Rimrock draw makes one thing undeniable. Humans were in North America far earlier than long-accepted timelines claim. This isn't speculation. It's supported by solid, dated evidence. Camel remains, stone tools, and microscopic residue, all preserved in undisturbed sediment layers. The impact is immediate. If people were living in Oregon more than 18,000 years ago, then other regions were likely occupied too. Sites once dismissed as irrelevant, mountainous areas, coastal shelters, volcanic zones, may now hold critical evidence. Archaeologists can no longer limit their searches to expected timeframes or assume the earliest history sits near the surface. Excavation strategies must change. Deeper layers once ignored as too old or barren could contain traces of human activity thousands of years earlier than previously recognized. Every layer now matters. The discovery also reshapes how we view early humans. The people at Rimrock Draw were skilled and deliberate. They crafted tools, processed large animals, managed resources, and survived harsh ice age conditions during the last glacial maximum. That level of ability demands a reassessment of what early humans were capable of. Most importantly, the timeline of human settlement in North America is no longer stable. Rimrock Draw isn't just a surprising sight. It's a signal that much more may be waiting to be uncovered. Make sure to click the cards on the screen now for more interesting videos.